In a previous video, I had showed how to take a z-score and find the corresponding area from a normal table. That's going to be part of the process that we look at here today. But we're going to take it one step farther. We're going to start with an x value, which is related to our data that is collected. And from that x value, we'll find its corresponding z-score. A formula is used to do that. Then we'll take the z-score that we get and find the appropriate area from the normal table. So it's a two-step process. In the question below, the times per week that a student uses a lab computer are normally distributed, with a mean of 6.6 hours and a standard deviation of 1.4 hours. Let's assume that a student's going to be randomly selected from this population. So, first of all, I'm going to start off by making a scale for my curve. I'm going to make both an x and a z scale though. The mean is 6.6, so let's put that right in the middle. That's an x value though. The z that corresponds to that would be 0, of course. There's a marking here for the next standard deviation above. So that's going to be 7, let's see, what's this? No, it's going to be 8. That's one standard deviation above. 5.2 would be one standard deviation below. 3.8, 2 standard deviations below. Okay, so we got our normal curve marked off pretty well here. That's a good start. He says, find the probability that a student uses a lab computer less than 5 hours per week. Now we can't just use the empirical rule here because that boundary does not fall exactly on one of the standard deviation integer markings. It's between -1 and -2 here. So the cutoff is 5. That's this point right here. We need to know what z-score does that correspond to. So that's going to be my first calculation here. I'll use the formula z equals x minus mu over the standard deviation. So you use the boundary 5, subtract 6.6 and divide by 1.4. Okay, it's a negative 1.14 z-score. Now we can write that in. Now that we know the z-score that corresponds to the cutoff of our shaded region, that's actually what we want to look up on our normal table. So we'll go to the normal table. We're looking for negative 1.1, negative 1.14, which is 0.1271. Okay, now we can answer the question. The probability that an x value is less than 5 will be equal to the probability that the z-score is less than negative 1.14. And that is approximately 0.1271. So 12.7% of students are expected to use the lab computers less than 5 hours per week.